Welcome to Sustainability Soundbites, presented by E&E Leader. Space-based solar power faces its infrastructure test. A new white paper makes the commercial case for orbital solar power, but a run of technical research from the past several weeks is quietly narrowing the gap between that pitch and an operating energy system. The UK's Space Energy Initiative recently published a white paper presenting space-based solar power, or SBSP, as a source of continuous, dispatchable electricity that could avoid the intermittency and storage challenges tied to terrestrial renewables. The premise, solar arrays in geosynchronous orbit, could collect nearly continuous sunlight and transmit it to receivers on Earth. The paper estimates space solar system could eventually reach a levelized cost of £10 to £30 per megawatt hours at scale, and cites Imperial College London analysis suggesting every 2 gigawatts of SBSP added to the UK system could cut annual system costs by £1 billion to £2 billion. Those figures remain projections, not demonstrated costs, and the paper itself acknowledges commercial economics are unproven. Power beaming is becoming a systems engineering problem. A Columbia University study, published July 29th, examined orbital configurations and radio frequency power transmission across low, medium, and geosynchronous orbit, modeling variables including satellite visibility, eclipse cycles, and how much time different orbits could actually beam power to a given location. Generation capacity alone tells only part of the story. Orbital position, beam availability, and receiver access are the equivalent of a terrestrial plant's capacity factor and grid connection. Japan and China are asking similar questions, with Japan's peer-reviewed Space Solar Power Systems journal updating its 2026 volume in early August around the Ohisama project, and a China Academy of Space Technology review published July 31st, calling for further on-orbit verification before large-scale development. Regulation is moving into the engineering conversation. On August 4th, the Institution of Engineering and Technology held a session on the technology, spectrum, and regulatory challenges around SBSP, with speakers from Space Solar and Ofcom, the UK's communications regulator. That matters because large-scale wireless power transmission cannot develop independently of spectrum management and orbital regulation, and the Space Energy Initiative's own paper names regulatory certainty as one of 4 conditions for commercial development alongside public funding, international collaboration, and public engagement. The question is not simply whether engineers can transmit energy from orbit, but whether developers can build a system, regulators can certify, and grid operators can use. NASA's numbers offer a useful counterweight. There is a wide gap between industry targets and independent assessments. NASA's own analysis of 2 gigawatt SBSP concepts published last year found life cycle costs of $61 to $1.59 per kilowatt hour versus roughly £2.05 for terrestrial wind, solar, and hydropower, or 12 to 80x higher, and concluded competitiveness would require improvements in launch costs and manufacturing beyond its baseline assumptions. That does not necessarily contradict newer projections, since the architectures differ, but it explains why headline cost comparisons need caution. The same caution now showing up in how credit analysts price execution risk into unproven power infrastructure. There are early signs of demand. Meta has reserved up to 1 gigawatts of capacity from US-based Overview Energy, whose satellites would beam energy as near-infrared light to existing solar farms, targeting a 2028 demonstration and 2030 delivery. Space-based solar no longer needs to prove sunlight can be collected in orbit or transmitted wirelessly. Developers now have to show those capabilities work together reliably, safely, and economically, a bet that echoes other space-based power claims hyperscalers are making about AI's growing energy appetite, and the kind of track record that eventually attracts the offtake agreements that make infrastructure bankable. The next several years are less about whether orbital solar is interesting and more about whether developers can turn demonstrated technologies into financeable infrastructure. Interested in a Soundbite sponsorship? Check out the Energy category, currently sponsored by Amazon. Reach out to our team for more information. Thank you for listening.